There are other useful improvement techniques that we will review in this lesson. The theory of constraints is a process of ongoing continuous improvement. Theory of constraints is an intuitive framework for managing based on the desire to continually improve a company. A definition of the goals of the company are established along with the metrics for critical measures. There are three basic measures to be used in the evaluation of a system: throughput, inventory, and operational expenses. Some of the concepts behind theory of constraints include: if a resource presents itself as a bottleneck, then things must be done to lighten the load. One should balance the flow of product through the plant with demand from the market. Dependent events and statistical variations are important. Each event depends upon the ones prior to it. Throughput is the rate at which the system generates money through sales. Inventory is all the money that the system has invested in purchasing things that it intends to sell. And finally, operational expenses are all the money that the system spends in order to turn inventory into throughput. Use this method for theory of constraints implementation. First, identify the system's constraints. Constraints must be identified and prioritized for maximum impact. Second, decide how to exploit the system's constraints. Manage non-constraints so that resources are provided to feed the constraints. Constraints may have a limit, so look for ways to reduce the effects of a constraint or look to expand the capacities of the constraints. Try to eliminate the problems of the constraint. Strive to keep improving the system. And finally, after the constraint has been broken, go back to step one and look for new constraints. The drum buffer rope concept pertains to our ability to reduce the effects of a constraint. In the presence of a bottleneck, we seek to increase the capacity or remove elements that slow the bottleneck. If the capacity of the bottleneck cannot be increased, then we work to maximize the bottleneck's output. There must be a continuous source of materials to the bottleneck. Machines have variation. Expect there to be too much work in process for the bottleneck or not enough work in process for the bottleneck. The ideal situation is to always have enough work in process for the bottleneck, but not too much or not too little. One way to do this is through the creation of a queue or buffer or product to feed the line ahead of the bottleneck to offset the effect of the bottleneck. A feedback mechanism is needed to control the release of raw material to the downstream equipment. One such technique is called the drum buffer rope concept. Drum is the beat of the operation and sets the pace of the line. Buffer is the work in process for the bottleneck. Rope is the feedback mechanism from the buffer to the raw material input point and releases only enough material to keep the buffer inventory at the right level. The drum buffer rope technique can be thought of as a pull-push system. There are several methods used to evaluate and implement improvements prior to full-scale deployment. A pilot run is a trial of a changed product, process, equipment, or system to gain experience and collect data about the change. There is also the opportunity to train operators and gather feedback. Pilot run objectives include finding potential implementation problems, localizing any negative side effects, and optimization. A simulation is a time-dependent trial on a new product, process, or system. These activities are deployed using computer simulation. This can be very cost-effective. when conducting a pilot run is too expensive or time-consuming. A demonstration is an execution of an improved process or system. If a product is involved, there may be a requirement to obtain an approval for any real or potential changes. Prototype testing is the evaluation of a developmental model that is close to production. It should be highly representative of the final state. A prototype should allow full functional evaluation.